Great, we're live.
All right, let's take that from the top. Thank you very much for joining us tonight for our virtual Macomb meeting. Good to see everybody. Got a great and timely talk tonight about things that will be very exciting next month. And in the meantime, let's do a quick run through our club business. As your president, I have an apology to issue to you on behalf of the club. There was a production error in the WAS calendars. It did not affect the beautiful images that you all submitted, but the calendars that we have been providing for the last decade are supposed to have US and federal holidays by default. When we ordered the calendars, the dates, Martin Luther King Day, Memorial Day, 4th of July, Thanksgiving, Canadian Thanksgiving, Christmas, were in the view frame. The production copies that we received lack the US and Canadian federal holidays. We apologize, that's never happened before, and we know how inconvenient that is, but we can say that the calendars are at least beautiful and contain all the WAS highlights and astronomical highlights. Again, deeply sorry about that. We've got we're in the period for membership renewal right now. A mailer will be forthcoming shortly with the accomplishments of 2020, the expectations for 2021, and a reminder about how dues work, because we did, of course, have the dues holiday on account of the COVID issue last and switching to virtual meetings. And other than that, I think I'd like to turn things over to First VP Dale Parton for his report.
Thank you, Diane. Looking ahead to our next meeting on February the 1st, Dr. Clara Castoldi, who teaches astronomy at Oakland University, will give our main presentation. Her topic will be the Kuiper Belt objects. The short presentation that evening will be given by our own Bob Berta. His topic will be the world's largest refractor. Then on February 18th, a month from now, our main presentation will be given by Dr. Ilyas Cholis, also from Oakland University. His topic will be antimatter cosmic ray physics. I did ask him to tone it down just a little for us. So that's what's coming up in the next two meetings. Diane, back to you.
All right, sounds great, Dale. Let's hear from Riyadh, our second vice president.
Thank you, Diane. Hello, everyone. Yeah, I visited the observatory during the last, just before the last meeting. Actually, it was on the 4th of January. Everything is fine. Everything looks good and clean. Both buildings are safe. All the equipment is still there, and nothing really new to report past that point. Of course, we're still shut down because of the virus, and this is something that eventually the board will make a decision on, possibly, hopefully sometime this year. And we'll see when that will happen. Of course, we'll notify everyone in the society. Other than that, that's all I have right now.
Fabulous. Thank you, Riyadh. And Secretary Mark Kedzier.
Hello, everyone. I have really nothing to report other than the two banquet prizes have finally been delivered. There was a University Optics eyepiece that was received on the 19th, and the other one that was supposed to go to Troy, about 15 minutes from my house, did a side trip to Chicago, and it finally arrived today at about 5:15. So everybody's got their prizes from my end. So that's all I have to report.
Fabulous. Thank you, Mark. Yes, our banquet prize has had some peregrinations in the mail. I can also report that the last of the other banquet prizes was hand delivered by yours truly, since it was wine and could not be shipped. So everything is in the hands of the deserving people, and we hope that they all take pleasure from their winnings. Adrian, Treasury.
Nothing new to report. I do have, I see the membership payments coming in through PayPal. So we've got those going, and I also still have all of the payments for the calendars that came in. I'll be working with the outgoing treasurer, and it looks like our deadline to get this done is next week because we've got another meeting coming the 1st of February, if I'm not mistaken. So still looking to get access to the bank account and other. I think I've got PayPal, but now I need access to the bank account and become a signer there. Then I can do a full report at our next meeting. So that's all I got right now.
Thank you, Adrian. And having been on multiple boards, I can say that the Treasury handover is always the most complicated logistically of any piece of the transition. So we're actually doing pretty good since the PayPal account is in your hands. And outreach, Bob Tremblay.
Okay, I have a little of a report. I gave a presentation about the Perseverance rover to my wife's class yesterday. This presentation was actually made by another solar system ambassador who graciously posted it on the Facebook forum. So I downloaded it, made a couple updates to it, and I'll also be giving that on February 16th for the Detroit Public Library. I am in the process of ordering the Night Sky Network pins for people that did outreach last year. One of the questions that I haven't seen before, the previous ones came in these little boxes that are disappearing here, these little plastic boxes. And I can either get them in plastic boxes or plastic bags. Does anybody have a preference?
As much as I like the boxes, having several of them, I think we can probably do a more ecologically efficient way of presenting things.
Okay, well, we'll do bags then.
We can talk a bit offline about it.
Other than that, again, if anybody's doing any online outreach, let me know so I can include it in my report for next week. Yikes.
I'm actually doing something on Facebook all the time. Every week I'm giving a report on something astronomy, and I'm getting some feedback from it. So there's another place that it's showing up.
All right, very good. And Dale Temia, Publications. Dale, you're still muted.
Okay. Okay, last time I looked, the WASP was still online. And the mailer should be going out by the end of this month. I think we're about ready set on the verbiage. Just need to get together with Jonathan on it.
All right. Well, we can move into the subgroup reports. Solar Marty isn't here, but having talked with him about the sun last night, there are some spots on the sun. They look, they're not huge, but they're good, and we have had a lull. So if you have the opportunity to see the sun, do check that out. Also, I can see that Bob Tremblay's background features the amazing stamps that are coming out from the USPS of the various views of the sun from the Solar Dynamics Observatory, which is my go-to website to investigate what is happening on the sun at any given day. So if you can score these stamps, they are beautiful. They're in various visible light spectrums, plus false color, ultraviolet, and extreme ultraviolet, and they are gorgeous. Double star group.
Not much to report at this time. I'm still kind of looking, whenever it's clear, obviously, at Betelgeuse to see its change in brightness. And that's something that's you don't even need a telescope for. So I kind of recommend that people would, if you have time and it's clear, take a look at that.
Excellent. Yep. Great time to view Betelgeuse. And I believe that is the cover story for, I think it was Sky and Tel arrived at the house today, and they're covering the dimming of Betelgeuse. So great time to be getting into that. Yeah, Riyadh will, even though we can't go hang out at Stargate right now, Riyadh will be keeping us apprised of the double star happenings to look out for, since some stars are easier to see at some times than normal. And History Group says nothing to report at this time other than the usual adventures in the WASP. I think we can pass things through to the Astronomical League.
Some of you should have gotten your reflector, and if you haven't, let me know.
All right, anything else from the AL?
Oh.
Guess not. I did receive an observing report by email. It is concise and I can read it to kick off our observing reports, but we did have David Levy wanted a word in, so let's hear from David before we segue into the observing reports. Let me get you off mute, David. Sorry about that. I can't take you up. There we go.
There, thank you. Well, again, thanks, Diane. I'm sorry about all that. And I always love to take a few minutes to say hello from Arizona to everybody. And also to do my quote of the week. As we were having an informal discussion earlier before the meeting started, everybody was talking about the eclipses that they plan to see in the next few years. And there are a couple of nice ones coming up, including a total lunar this year. In fact, I think two of them that we'll be able to see. And so for my quote this time, I'm going to quote from Thomas Hardy's At a Lunar Eclipse. And you're lucky because I was going to quote from In Memoriam, and In Memoriam would have taken about 3 months for me to read through. This is a lot shorter because Thomas Hardy writes a lot more concisely. Thy shadow, earth, from pole to central sea, now steals along the moon's meek shine, in even monochrome and curving line of imperturbable serenity. How shall I link such sun-cast symmetry with the torn troubled form I know as thine, that profile placid as a brow divine, with continents of moil and misery, and can immense mortality but throw so small a shade, and heaven's high human scheme be hemmed within the coasts yon arc implies. Is such the stellar gauge of earthly show, nation at war with nation, brains that teem, heroes and women, fairer than the skies. Thank you very much and let's enjoy the meeting.
Thank you, David. Hardy, in addition to being quite the poet, wrote one of my favorite depressing novels. So always nice to have a shout out from of him.
From Thomas.
All right, so as far as observing reports go, we do have a dispatch in brief from the Wien Observatory. Gary M. Ross says, the sun, 21st of January, meridian, transparency excellent, but seeing fair, it's windy. One group, 4 spots, of which one was a tiny pore. It was using a 50 centimeter refractor, f11, 60 times magnification, a custom eyepiece of uncertain origin, no autofocus eyepiece, apochromat objective, and a sub-diameter mylar filter. So, sunspots being seen by our members. Keep the observing reports coming in. We appreciate it. And I think, hopefully, in between the conjunction last week, the conjunction last night, and the sun, we have some other observing reports. Throw your name in the chat if you would like to share. Anyone? Yes, Jonathan.
So I know our president was observing last night. We went out for a walk around midnight to beat the crowds, and the clouds miraculously opened as we were on our walk. And as we got home, we pulled out the telescopes and pointed them at Mars and saw Mars and Uranus close together, which was pretty cool to see. And they're pretty close together tonight. I think it's, last I checked, it was pretty grim looking outside, despite the fact that today was beautiful. But they'll be relatively close for the next couple days. So if we do get any clear skies, try to see them, because Mars is in a place without a lot of bright stars right now, and that makes it helps Uranus stand out against the similarly sixth and seventh magnitude objects that sometimes make it a little bit hard to find. So
Yes, we also got the triple conjunction last week that we were just able to fit Mars, Jupiter, and Saturn in our 66 millimeter and or the 10 by 70 15 by 70 binoculars. So they were spaced far enough apart that the three planets were basically all at the edge of the field of view. But it was pretty cool seeing three planets in one field of view. And Riyadh and then Paul have some reports to share. Riyadh.
Yeah, just quickly, I just want to mention that, of course, since the observatory has been closed, as usual, we've been having, whenever it's clear, we've been having virtual observing through Doug Bach's Northern Cross Observatory. So if you're available on a Saturday, look him up, and maybe the Saturday, if it's clear, I'm not sure, Doug, if you have time. But if it's clear, we'll probably be doing some observing. And Doug says yes. Thank you.
Thank you, Riyadh. Excellent point. Yes, we'll hope if it's clear to get y'all an email blast inviting you to join the fun at the Northern Cross Observatory. Paul, why don't you share what you're up to?
All right. Hopefully my mic is working here.
I can hear you.
Oh, good. All right. I finally have a couple I'm reasonably proud of. These are from about a week ago when we had a rare unscheduled clear night. And let's see here. There we go. That's the Flaming Star Nebula. That was actually from a very, very poor night. I'm surprised I got anything. The transparency was awful. I could not really see the Big Dipper. But that is, I don't know, about an hour and a quarter, or maybe about 2 hours, I think, of integration from my driveway in Rochester Hills with an L-enhance filter. And then the other one, this one I really like. This is a couple hours on the Horsehead. This is the first time I've ever actually seen it with my eyes. And it was coming through a camera, but I've been playing with astronomy for many years and never actually saw this object. So those are my two. And let me stop sharing here. Where did it go? Give me a second here. Oh boy. Give me a second here. The view collapsed to a mini view, and I can't figure out how to expand it.
Okay, we're still looking at the lovely picture of the Horsehead,
Yeah,
which I have a very fond memory of seeing quite some years ago through the club's 22-inch dog.
There we go. Yeah, I can get lost looking at that one, and it's probably even better in real life than it is compressed on the screen here. Let's see here. How the heck do I stop sharing?
Yes, we're looking at the tile view again.
Yeah, I know. Let's see here. Screen 1, screen 2. I don't see an option to stop sharing. Is it at the bottom of the screen?
sorry, Paul, I actually took the sharing back from you and made Diane the presenter again.
Oh, okay. That's why I couldn't stop it.
Do I need to give the ball to Paul? Let me do that.
No, I'm good. It looks like I have stopped sharing.
Okay.
Yeah, I thought Paul was just trying to
Okay.
stop.
Okay, very good.
Yeah, I
All
was
right.
trying to stop sharing it,
And
but I couldn't find the button.
looks like while we were talking to Paul, Doug has entered the queue with an observing report. What have you got for us, Doug?
Okay, so I've only had one partial night this month. It was on the 10th. The night before was the 31st of last month, and I got up 3 hours in on this object here.
Ooh.
And I've actually got I went back and found that I actually have a better one of this from a year ago where I have 8 hours of data collection on it, but I thought I'd show you what I got on the 11 days ago. So I see 3146, I think it is. Let me check that. Yeah, 3184.
That one looks a lot like a lot of artist renditions of the Milky Way, doesn't it?
Yes, it sure does.
And I think this is up in Cepheus. So
really
that's all I got. Well, yeah. Let me see here. Let me check something else real quick.
Is that the pinwheel?
No.
You're going deeper in. That's a small one.
Yes. So
It's
this
deep
was
sea.
this was from a year ago. The same object. This is 8 hours of data. The other one was 3. But I think so. I'm going to take more data on this object because I got a smoother background now. It's kind of some different, better techniques. So that's all I got.
All right. Well, that was beautiful. Adrian, you've got one, and then we can move to In the News in the Sky.
All right. Well, I got lucky enough to have one of my images will be up at Camera Mall sometime before the week goes out. I was in a contest and one of my Milky Way shots made it into a contest. I didn't win. There was another Milky Way shot that was a little prettier, shall we say. But as far as observing, I figured I'd share something that I actually attempted, which was, let's see, I guess I'll do a screen broadcast. Whoops. Let's see if I can find it. That didn't work. I'm stuck in a hopeless loop that is saying screen broadcasting stopped, so I may not be able to share it. Okay, there it goes. All right, so we'll try this one more time. And I'll share my screen. Okay, so it's starting. All right. Anyone see this crummy little image of Orion's belt and sword area?
All right.
So this was taken in my backyard, and it's one frame. I take with a modded camera. So I'm basically convinced that I can go, instead of having to go all the way and travel somewhere, I'll be able to just go to my backyard, try my modded camera, and try getting some frames with that, and see if I can see what I can do with it. So on the days I just don't feel like hopping in a truck and traveling for 3 or 4 hours, I've basically discovered that I do have another option. So
people with narrowband filters can get amazing shots from inside of incredibly large cities. It's amazing what they can do with good filters.
Yeah, I'd have to find one for my DSLR. The camera is already modded for full spectrum and already has a light pollution filter in it. So, you know, I'm not as surprised that I got something from the Sword with one, you know, with what basically 60 seconds. I think it was a minute. What I'm surprised is that I got IC 434. It was faint in that image, but I was surprised I got. Say it again.
What focal length?
That was at, I want to say it may have been around 100 or 200, something to that effect. 200 millimeter.
Oh yeah, and that's a single frame.
That was a single frame.
Oh,
60 seconds.
You can get a lot of good stuff out of there then with stacking.
Yeah, so I basically need to just, and you and Doug will turn this into an astrophotography meeting, but
I was gonna say, yeah, it's like this is
we
cool,
don't want to
but
do that.
we were getting to the point where
I got more work to do to get even better images with that, but that was a promising start, and that's it for my observing report.
Adrian also has a stunning shot of the moon, which is astrophotography, with a fortuitously placed bald eagle that I got to see on Adrian's Facebook page.
Yeah, I should download it, but I won't do it now because we have to move
Yeah.
the meeting along. But
Yeah, do that during the break. That's a hell of a shot. I really enjoyed that.
I will
Alrighty.
go and get it.
We got In the News in the Sky featuring Jeff McLeod. Take it away, Jeff.
All right. Can you hear me?
Yes.
Okay. And are you seeing my screen now?
We're seeing your face.
Yeah, Jeff.
Seeing my face. Hold on. Always takes a minute to figure this out. Let's share PowerPoint.
There you go. Now you should be able to share.
You're good.
Right. And
Sharon, we're good.
then we'll put this down here. Oh wait, this is what I want. I want this over here. All right, in the news, in the sky, something a little different than traditional report. That's just how I roll. First thing to report, if you are into such foolish notions as numerology, 12121 is a palindrome if you write it out this way. Of course, that's broken if you write 2021. So anyway, I did this last time and I thought it was fun. I'm going to give you some stats on what's happened since the last meeting. So it's been 17 days in that time in the observable universe, 1.5 million supernovae, and about 7 billion new stars born. Here at home, we've had approximately 300 meteorite impacts large enough to actually hit the surface of the Earth, and about 1,700 metric tons of dust. So the Earth is getting heavier by some measure. We have gone approximately 500,000 kilometers spinning around here in Detroit. If you're somewhere else closer to the equator, you've gone farther. We've traveled about 70 million kilometers in our journey around the sun and 323 million kilometers in our trip around the galaxy. And in that time, 17 days, the sun has converted about 6 billion tons into pure energy.
What's your trivia site, Jeff?
I kind of sourced all over the place. I mean, I do all my own math, but so for the sun, that came from NASA. I'm not remembering where I got the meteorite impacts, but I try to at least make sure that I can at least trust the source for the most part. But again, these are averages. There's also huge errors on either side of these, so it could have very easily only been 100 meteorite impacts in the last 17 days. It just means that now maybe we're going to get even more in the next 17. But on average, the site I found said 51 per day. And then some other random stuff. The Andromeda Galaxy is 160 billion kilometers closer to us, closer every day. the warm embrace of Andromeda's dark matter halo already affecting us. Voyager, about 25 billion kilometers further away. Light, as we know, pretty darn fast, has gone about 442 billion kilometers. That's just under 3,000 astronomical units. So 3,000 times the distance between us and the sun in those 17 days. And the LHC always putting everyone else to shame. Particles, if they're running right now, which I'd have to talk to Jennifer to be sure, but 16.5 billion trips around, and the possibility of producing 1,400 trillion collisions. That's a lot. This day in spaceflight history, well, maybe not this day, but yesterday in 1930, Buzz Aldrin was born. Despite the portrayal in some first man movies, Buzz Aldrin is an awesome guy. He literally wrote the book on Orbit Rendezvous, so you'll never hear me talking smack about Buzz Aldrin. Also, hugely beneficial in figuring out how to do spacewalks safely. And then Miss Sam, the I used to know what kind of monkey that is. It's a rhesus monkey. 1960s, the U.S. launched the Mercury Little Joe Capsule 4 on a suborbital flight. So this.
Jeff, could you move whatever the little tiny thing is that was in front of Buzz down to the bottom?
Sorry, I thought only I could see that. There we go.
Thank you.
All right. This almost didn't make my cut, but if you're into SpaceX, it seems like they've become a polarizing topic amongst the astronomy and spaceflight community. But if you like them, this most recent launch on the 20th was the 8th reuse of this booster. So that's a pretty big milestone for them. However, Discovery did 39 flights, so they've got a long way to go before they can compete with the reusability of the shuttle. And they don't recover their second stages, so reusable, yeah, part of it is. Okay. So gonna do something a little bit different for in the news. We're gonna do in the journals. If you want to keep up on the absolute forefront of astronomy, I highly recommend this website, rixiv.org. This is basically every professor that I have uses this website for their journal articles. They do more than just astronomy. They basically do all of science, but they have an astrophysics section. And then you can see here, they subcategorize that into galaxies, cosmology, planetary, high energy, instrumentation, and stellar. So if you have a niche, you can find exactly what you're looking for. It is pretty high level, but there's some really interesting stuff that comes out of this. And you can also go back. So if you want to see a very famous historic paper, well, if it's before 92, it'll be in here. So I'm just going to go through 3 categories, and I just found a paper that I liked, and I'm going to do my best to walk you through it. So for planetary, the future large obliquity of Jupiter. So our planet has a tilt relative to its orbit of 23.5 degrees. That's what gives us our seasons. Jupiter, being a rather large planet, has a rather low tilt. And so this paper was researching whether that tilt angle, it's around 3 degrees, is actually stable during long time scales. And basically what they found out is that it's not. So Jupiter will tilt rather substantially, or could tilt rather substantially in the next 5 billion years. So these plots just kind of showing this is the obliquity, or that tilt, and showing different degrees that it could tilt and the probabilities of getting those. And so then there's some other curves here. Don't worry about the math. If you're interested in any of this stuff, you can reach out to me, or you can go on the website and read the full paper. Much better to read the full paper. This one is really just more for the pretty pictures, but stellar is really interesting branch of astronomy, but also extremely high level. Any of the papers that are coming out on stellar physics are just really dense. So this is a first attempt at 3D simulations of the oxygen burning shell within large mass stars. So these are supernova progenitors. And so this is stuff that's happening before a star goes supernova. And so they're looking at what is this oxygen shell doing. And so in these beautiful plots here, this is basically plotting the magnetic field versus, let me see here, the thermal pressure. This one over here, magnetic field strength, radial velocities, and then this one is silicon mass fraction. So this is basically where the silicon is and where the silicon isn't. There were some pretty interesting things in this paper about how neon is creating fields that are quenching convection within the oxygen shell and how that relates to what is going to happen later on. So pretty interesting stuff. But I don't know, supernovas are very interesting, but the physics is rather complex, if I'm honest. And then lastly, galactic. I thought this one was pretty interesting. The observed rate of binary black hole mergers can entirely be explained by globular clusters. So this is based on LIGO data. Everyone knows about gravitational waves being detected, but where are they coming from? And I think most people's assumption was that they were seeing mergers from the cores of galaxies, where you had a binary black hole system and you get this new supermassive black hole. It turns out that at least this paper seems to indicate that you can actually explain all of the data merely by mergers that are happening in globular clusters, which is pretty interesting. So in the sky, I looked around and there wasn't too much going on. And so I decided to, rather than tell you what's in the sky, issue a challenge. So for the beginners, observe the straight wall. It is supposed to be up tonight, but I guess tonight's not going to be too good of an evening to view the moon or anything else. So you're going to have to try on the next cycle. It's really only visible for like one night out of the cycle, if I'm remembering correctly. This shadow here, once the terminator fades over to the other side, it basically disappears. So you got, I think you get a few days to see this shadow here. So the straight wall, if you've not seen it, it's pretty awesome. About 40 miles long, this straight wall. For the intermediates, observe Uranus. Jonathan mentioned looking at it next to Mars. It was better to observe this a few days ago, but it's probably still an interesting thing. And really, the challenge is just to observe Uranus, not that it's close to anything else. It's just a challenge to find Uranus. So dipping below Mars about 5 degrees. And then for the advanced among us, I certainly won't be doing this. Psyche, the most metallic asteroid in the asteroid belt, is in Taurus right now. And it's actually at its kind of stationary point. So I would assume a pretty difficult target, unless you're one of these fantastic imagers that can actually pick up some of this motion. You would have to observe this over a couple of nights. So this one's pretty challenging, I would say. And that is it for In the News and In the Sky. I hope you guys enjoyed it, and you can either take my screen. Oh, I'm going to stop sharing. There we go.
All right, thanks, Jeff. And we can now have a little break. If you've got pictures, please, this is a great time to show them, and we'll reconvene at 8:30 for our feature presentation.
All right, I'm about to post that picture up Diane talked about. It'll.
Can I have a moment?
Oh, darn it. Well, there's the picture.
No, you can leave the picture up. It's fine. I wanted to find out. I think the only person, there's maybe a couple people. Does any of you remember Beverly Court?
I don't remember.
No, you wouldn't.
Yeah,
She was a member in the 70s. That was my mother.
Yeah, she passed away.
I remember your mother.
Yep.
Our condolences to you. Absolutely.
So she was a member of the club. I just want to mention she was a member of this club. She joined the year I joined, 1973, until probably about 78, maybe. I don't know when she moved to Lowell. I just don't remember when that was, but probably around 78. She passed away a week ago tonight, so at age of 91. Just wanted to let you know.
Sorry about that. I remember her, and our condolences to you and your family.
Our condolences all the way across.
Thank you.
Absolutely.
Yeah, my condolences as well, Doug. I think I mentioned it when you first broke the news on Facebook.
I just wanted to. I figured there were a few people who remembered her that might wanted to know. So, she was 91. She died at the hospital of COVID-19.
Yeah, I'm sorry to say that unfortunately also my father on December 22nd also passed away in the hospital from COVID. Same thing.
Yep.
I am sorry to hear that, both of you. Dale Teamy's father-in-law also passed away right before Christmas from COVID. So it's that would also be the grandfather of our member Brian Teamy. It's definitely been a grim 5 weeks for many members of the club, and a reminder of how important it is that as much as we miss one another, we all be responsible. Very sorry to hear that, Riyadh, and Doug, and
Yeah, thank you.
All right, on with the pictures.
All right. Trying to
You're going to show the pictures of that picture?
Yeah.
Adrian, I didn't see the picture before this one. It just said Adrian sharing screen, and I didn't see the actual photograph before this one that you had earlier.
Okay, so now are you able to see it?
I see this one, right, but the one before it, I didn't get to see it. I'm not sure what happened.
Okay, yeah, I think it was the same image I was trying to share. That's the bald eagle over the moon that I took today. I'm not sure which one photo bombed which.
I think the picture that you were showing earlier, wasn't it of Orion? That's the one I didn't see.
That's the one you didn't see?
Yeah.
Okay. And that's in that was in Lightroom. So this is the cool eagle one. Since they were sufficiently far enough away, I was able to keep the moon in focus and get the eagle. And it didn't turn out, the eagle didn't turn out too bad.
Yeah, it's
so
beautiful.
that one, so that was today.
Oh, by the way, do you mind if I just add a little good news here? Jeff and Janelle are now engaged, and we want to congratulate them on that good news. Isn't that great?
Fantastic. Congratulations.
There's what we needed to add to this. That's a wonderful piece of news, and we as I said to Jeffrey, he hit it out of the park with that one. She's quite something.
Yeah, we
All
were
right, there you go.
cooking dinner and didn't hear any of this. So
yeah. Okay, congratulations. It's just
thank you.
just wonderful news, and yeah. Janelle, you're gonna have to live with Jeff now, but hey.
I've been doing it for 3 years.
I got it. I love it.
So this is this is that image. This is a single minute frame that I took from my backyard using my modded camera, which is it's modded for full spectrum. A 400 millimeter lens. I think it was shrank to
modified camera. Is that what he's talking about?
Yeah,
it's beautiful.
So what it does is our cameras normally have filters on them to filter out all but certain spectrums of light. This camera has had all those filters removed. So if you've heard of infrared shooting, I mean that's what it's called. you see other wavelengths of light, and they're represented with different colors with that camera. So let's see, this was shot at 100 millimeter. Dale, you were asking that earlier. So this was a 100 millimeter shot, a lens on top of that camera aimed right at the belt region. I expected to get this. I knew I would get this in 1 minute. I didn't expect to get that minute. I didn't expect IC 434 or the flame.
Can I just ask? Roger Ween was is our main presenter tonight, and he has not gotten the chance to test his setup yet. So I wanted to make sure he had the opportunity to do that.
Excellent. Let's do that, Jonathan. Sounds good. Remember, we're reconvening at 8:30 sharp, everybody.
Thanks, Adrian. That was nice.
Roger, are you at the computer now? I'll send him a message. I think he might be away.
I'm here.
Oh,
yeah.
go ahead.
No, I just had to. Had to find the second mute button and unmute both of them. So here comes the camera. I think. Okay. I think I can see myself here, and I'll get the PowerPoint up and share it. So I think we can do that too, just fine. Oops, let's see. There we go. Now I wanted to check one thing. Says it's being shared at lower resolution, so hopefully that's going to be okay. And let me check one thing here, and that is see if we get some sound.
It's not. It isn't showing the presentation view. If you intend.
Not yet.
Okay.
No, sorry, that's fine. I'm not in there yet. So let me see what I want to show here. First of all, let's see if this video works. So if I play this, is it going to show it as a video there on your screen?
Looks like it. Looks good.
Very good. That one's without sound. So let me stop that one and move on. Actually, let me get out of that and go find our sound recordings just to see if something works. Turn this off. So I don't know if you can hear anything.
Yes, I think so.
It'll be a little louder in a second, I think.
Yep.
Okay, good. Then I think we're all set. I'll bring it back to the beginning. I don't have a whole lot of sound, but it's always nice to have some. I've been enjoying your meeting. My first 2 decades of life, I was as much of an astronomer as I could be at that age, and we had a lot of fun. And I should get back into astronomy, but I'm having too much fun on Mars. But we have the biggest telescope on Mars, and that's probably something you'll be interested in. We should be doing more astronomical observations from Mars. We tried to see one comet as it came by Mars, comet sighting spring, about 4 years ago. But it was kind of a dud. By the time it got right near Mars, it was disintegrating and getting very dim. So we didn't really make much of that. And then our telescope actually is something that in some senses prevents us from seeing the planets. As you know, any telescope that is focused at infinity and gets the sun in it will probably damage something, especially if it has an eyepiece or a CCD or whatever detector. And so there's a lot of risk aversion to getting our telescope pointed at anywhere along the sun path. Just because if the rover were to freeze up, then the next day we would be toast when the sun came by. And so we do not ever look into the ecliptic above the horizon with the thing focused at infinity. And so that prevents us from looking at the planets, including Earth so far. I've wanted to try to find out when the Earth would be as far away from the sun path as possible and get an image of it, but we haven't done it so far.
It's an incredible thought.
Yeah. We would see the crescent of the Earth. We have enough where the ChemCam has the highest resolution remote imager on Curiosity. It's black and white, but we would get it and could see that it's a crescent, which none of the other cameras can really do at this point. But we just haven't done it yet, partly out of this risk aversion.
Understandable. Well, thank you very much for being here at our meeting, and they're certainly easier to attend the last year than they were previously, because they needed you to drive to Bloomfield Hills or Warren, and I think that's a long drive for you. So
yeah. Well, Dale Parton was gently persistent on this, so you guys have me today. So. But yeah, I think perhaps some of our things will change, and maybe we will have more remote meetings from here on out, just because of the opportunity to attend from much farther away.
Yep.
Or even, even if people are half an hour away, it's a big pain, and much better if you can do it remotely in some senses.
Yeah, we do have a lot of interest in doing more remote events. So,
as someone who has lived half an hour or more away from all of our meetings throughout, I feel that one. No, thank you very much for joining us, and really excited. And I had my camera off, but I was smiling when you were talking about the biggest telescope on Mars, because that is a very cool fact that I think a lot of people aren't aware of.
Yeah. And so we'll have two of those as soon as Perseverance lands, because SuperCam, which is on Perseverance, and ChemCam, which is on Curiosity, the telescopes are almost identical. They're both 110 millimeter aperture telescopes, and so I think the next largest is maybe something like a quarter of that size, a quarter of that diameter, so much less light gathering power.
I think in retrospect, Perseverance was definitely the right name for Mars 2020. So.
Oh gosh, yeah. When COVID came around last March, of course, we were very much concerned about people losing their lives. But me personally, I was very concerned about this is going to change everything with respect to what I do. And in fact, in the end, the only thing that it really changed was that I'm now staying home the whole time. Maybe I'm sure I am more efficient, actually, just not having to go anywhere. But yeah, so thank God that the people working on this were able to continue. There were a few scares as it was getting toward the launch last June and July. The whole team was COVID-free for a long time, and then as it got up on the rocket, there were several people that got COVID, and they did have to slow things down a bit. We missed our initial launch date by about I think 9 days. And one of those was actually due to, or some of those days were due to a leak in the second stage fuel tank. And it was already up on the rocket, of course. And so then what do? And so the United Launch Alliance, they called in their expert welder. You probably don't, I didn't want to hear this, but I did. They brought him to the Cape and they got him all the way to the top of this rocket. And we didn't hear anything for a couple of days, but then we did hear that he was up there dangling upside down with his welding machine, with his welder, and got the leak stopped up. And so the rocket was able to launch. But yeah, we had a window that extended about to the 10th of August. So we were 10 days from the end of the launch window. So it was a little bit nail biter, but yeah.
I can think of very few scarier prospects than somebody with a torch working on a rocket with a fuel leak.
Yeah, I'm pretty sure I saw a Soviet era video where that didn't go so hot. Yikes.
Yeah. It was really a sad thing that we couldn't be at the launch because that's usually when the whole team comes together, actually for the very first time. And we were just expecting to have just a great time. It's a team building event because we're going to be working with this team for a long time. And we just couldn't do any of that. So I was really kind of in mourning about that. Some people had the privilege with curiosity to actually go up to the top of the rocket as well. Not myself, but a few of my colleagues. And that kind of thing is just almost once in a lifetime thing. I've had 3 major missions now, and so those are exciting times. And then, of course, missing the landing. Go ahead.
No, go ahead.
And then I was just going to say, and missing the landing, I'm going to be at home for the landing as well. Of course, we'll be doing outreach, lots of publicity events from here, but not going to Jet Propulsion Laboratory for the landing either is a downer. But we'll be, and I think, I know it will be more difficult to operate the instruments from home instead of together as a team, but we're just bracing ourselves for it, expecting that things might take just a little bit longer, but we'll get through it, and more than get through it, we'll be relishing it all as it happens.
Excellent. Well, we're really looking forward to the landing and all of the data coming back. So.
Oh yeah, it's been on the calendar for a good long time.
Yep. I should mention I was just actually doing some interviews today, so I'm wearing my shirt. I don't think you can see it, but if I stand up a little bit, you'll see the patch there that says Mars 2020.
Nice.
Yeah.
All right, well, we're just about at the appointed hour. It's 17 people on YouTube so far, so hopefully we'll see more people come back after the break.
Yep. All right. Well, it is 8:30 p.m. Time to reconvene our meeting for the feature presentation. So this is where I hand things over to Program Chair Dr. Dale Parton to take it away.
Okay, thank you, Diane. Well, needless, I don't think I have to say, I'm very pleased tonight to introduce Dr. Robert Wiens. Thank you so much, Roger, for coming to be with us tonight. Dr. Wiens didn't start his astronomy career with a doctorate working at NASA. He first got acquainted with Mars by sketching its features as seen through a telescope when he was 11 years old. He and his brother built their own telescope specifically for a close approach of the red planet. I thought that was pretty amazing. He's been involved with several missions at NASA exploring the moon, Mars, and comets. He's currently the leader of the ChemCam laser instrument on the Curiosity rover, which has been exploring Mars for about 9 years now. Man, I remember when that thing landed. Where have those years gone? It doesn't seem that long ago. He's also leading a group of French and American scientists who work on this mission. Since 2014, he has also led the development of the SuperCam laser instrument, which I'm sure we'll be hearing about tonight, developed for the Perseverance rover, which is on its way to Mars and landing in just a few weeks. I recently heard him speak on these missions to an organization called the American Scientific Affiliation. It's a Christian organization for scientists that I'm a part of. It was then a bit of a rush to get him here to speak to us before Perseverance lands, because he'd be way too busy after that. Incidentally, after we hear his presentation tonight, some of us may be interested in picking up a copy of his book entitled Red Rover: Inside the Story of Robotic Space Exploration. Get this, from Genesis to the Mars Curiosity rover. It kind of piques my curiosity, pun intended. So I hope that you are all looking forward to this presentation as much as I am. The topic tonight, exploring Mars with NASA's Perseverance and Curiosity rovers. Dr. Wiens, it's all yours.
Well, thank you so much, Dale. Yeah, it's great to be here. And as I was saying just a few minutes ago, I've really enjoyed your meeting so far because I love astronomy, and all of that comes back to me from some decades ago. It was a 6-inch reflector telescope that my brother and I built with or assembled, I should say, with our paper route money as kids. And so we put it, we didn't even have the money for the tube yet, so we put it on plywood, the mirror and the eyepiece and the secondary mirror, and then we mounted it on a fence post originally. So anyway, I've loved astronomy, and I never thought I'd get to do this kind of work. By the way, the Genesis that's in my book is the first major NASA mission that I was on, which was the first robotic mission to come back from deep space, and so that brought back solar wind in 2004. It crashed when it landed. The parachute never came out, and I was in the front row of the VIP and reporter section when that happened, and I had 20 microphones in front of me immediately with the major networks. But the amazing thing, really a miracle, is that in spite of that crash, we got our samples back on Earth, and so within 6 years, we made the cover of Science magazine with our discoveries, and so that was one of these tragedies that's turned into triumph. So I've just had a charmed life in some ways. if that had happened on one of our Mars missions, we wouldn't hear back from it again. And we're certainly hoping for a successful landing in less than 30 days now. So I just had to put this picture in here just to remind us of some of these features on Mars and what they look like to our eyes. Maybe some of you have better telescopes now, but this, except for all the lines there, which sometimes we thought we could see, it's a little bit like it looked to us sometimes. And I'm so excited that Perseverance rover is actually going to Syrtis Major, which is one of the easiest parts of Mars to see and sketch. And it's just over on the left over here. And of course, this always looks right side up to me. When I see another view of Mars, it always looks upside down, just because I got started with a telescope. Anyway, this was from this is from Giovanni Schiaparelli, of course, in the 19th century, promoting the idea that there was life on Mars and that the life was creating canals. Anyway, I'm going to skip forward by a long ways just because we don't have time to go through some of that. But I reviewed a book this summer by Bill Sheehan and Jim Bell, which is going to come out in University of Arizona Press, which is just a great compendium. It goes through chapters of all the astronomical observations of Mars. So if you can get that when it comes out in 9 months or whenever it is, it'd be great. So our modern era kind of started, I'm going to skip Viking and Mariners as well and just say that the rover era started in 1997 with Sojourner. And this rover was so small you could have just held it in your arms, of course. It was just about 20 pounds. But it really lit a fire inspiration for NASA. And so in spite of the failures of 1998, the Spirit and Opportunity rovers NASA decided to go for twin rovers in the next opportunity. And these were fantastically successful. The big thing was that they didn't, although they were able to rove very far and live for a long time, much longer than we thought, they didn't carry a lot of scientific payload. And so the Mars community, the NASA community really wanted to have an opportunity to get much more of a mobile laboratory on the surface of Mars. And so we got our wish. And so on August 8th, 2012, Curiosity landed. And this had something like 160 pounds of payload, including all kinds of different devices. I'm going to talk more about Perseverance tonight than I will about Curiosity, but 10 instruments and including gas chromatographs and all kinds of things that seem to only belong in a laboratory. So we're still using those, every single instrument on this rover. So that's shown here. And this dashed line, if you can see that, is the traverse of the rover of the last several years. And Curiosity is right where that star is, and we have a lot of really amazing terrain to go. I'm having a really hard time tearing myself away from this mission to get to the Perseverance rover to give it my full time starting next month, as I have to. I kind of shared these as we were developing SuperCam and Sherlock here, but now I've really got to give Perseverance my full attention pretty much. But we came, of course, from the low part of Gale Crater, and this was sort of the area that we had always been intending to spend most of our exploration time. We got to Vera Rubin Ridge in 2018. By the way, this is named after the astronomer Vera Rubin, who discovered the rotation rates of galaxies. So we were very excited to name that after her. But there's another thing, and that is her son, who I think is even older than I am already, is part of our science team. And so it was a kind of a double honor to bestow this name to this ridge, which is about a 6-mile long ridge and about maybe 100 meters high. And we didn't know why it was there at the time. So that was one of the sort of curiosities, no pun intended, that we were trying to study. It turns out we figured out that the rock is very hard along this ridge, and it is and so all of the mountain that we're climbing up, the surface has been deflating. It's been actually being weathered down by the wind storms on Mars, and over billions of years. And so this ridge appeared, which was at one time underground and consisting of harder rock, but it's not a different composition. What's happened is that water percolated through and in this certain area and caused this rock to harden into some, by giving it a sort of a harder cement than the sediments had around it. And then we went along into this clay unit up here and have been finding a lot of organic material in there, more than anywhere else along the traverse, consistent with the idea that clay minerals tend to absorb and protect organic materials. And so that's been an amazing discovery that we've had, because before this mission, we had no idea whether organic materials existed at all on Mars. And so we're heading up towards the sulfate unit, which is a transition from the lake bed, that the sediments that we've been in all this time, over to probably a drier period on Mars when more wind-blown dust was getting deposited into and eventually formed rock. But we think that's going to be punctuated, that there was not just one change of climate, but rather that there were a number of cycles back and forth, but over time it was getting drier. And then we're going to go way up into this gully, this flow channel, Giddes Vallis, and I think there's some amazing things that we'll find up there as well. So I do intend to keep one ear to the ground on this mission, but we're moving forward to Perseverance as well. And the major discoveries, just to reiterate a little bit, is that Gale Crater was a lake. And in fact, so much material was laid down. We've climbed up 400 meters, 1,200 feet, and we're still in lake bed sediments. And so this lake must have lasted at least 1 million years. We think we found a couple of places where it may have gone dry briefly and then re-wetted. So there may have been a bit of a series of lakes, but this is a long time, and so we had no idea of this before this mission. So that is telling us that conditions on Mars were habitable. The scientists who modeled the climate and the atmosphere on Mars going back in time are still a bit stymied as to how Mars was warm enough in these time periods, 3 billion years ago and longer, given that I think probably you as astronomers are aware of the faint young sun paradox, which makes this problem even harder to do. But there were open lakes on Mars, large ones, oceans probably as well, and this lake at least was neutral pH. As our leader said, John Grotzinger, back in 2013, when we first sampled the clay minerals and found that it had neutral conditions, he said you could have drank the water here. And we found a lot of water-form minerals. Some of the minerals we found in the cracks in the rocks. And so over 3 billion years, these rocks have cracked, and the water has percolated through the cracks in these rocks and deposited other minerals. And we can find out a lot from that, but it seems as if perhaps the hydrosphere, the groundwater underneath, was habitable long after the lake was gone. And so this is just a number of very interesting things from a standpoint of habitability. And then we found a lot of the materials that are building blocks of life. The elements carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are known affectionately as CHNOPS. We found boron. That's one thing we discovered exclusively with ChemCam, and we've been monitoring these as we go along. And then the SAM instrument has been studying the organic molecules and found that there is methane in the atmosphere. So it's an ongoing mission, and so we're excited about that. So I'm going to take this opportunity just to say, why don't we look for fossils like we see on the left? Well, just a reminder that on Earth, these fossils only appeared in the fossil record only 650 million years ago at the Cambrian explosion. Before that time, especially long before that time, there were only single-celled organisms. And so what we look for in Earth's history if we go back to the time of most of the surface of Mars, is we find only what we call microbially induced sedimentary structures, or MISS. And the best known of those, in fact, a whole category of them are stromatolites, and they can either be cone-shaped like this or dome-shaped. And what they are is basically slime. At that point in time, it was the first material that actually caused sediments as they were falling into a lake to adhere in such a way that you could have sediment layers that were steep like this. And so we can go back and we can find that. And not only that, but there is carbonaceous material that's still left in them. We don't find the amino acids or proteins in these things 3.7 billion years ago, but we do find them in the equivalent stromatolites from about 1 billion to 1.5 billion years ago and on up to modern time. So just to reinforce that, the history of life on Earth, the Phanerozoic here, less than 650 million years, is where we have all the large fossils, from anything from a leaf to a dinosaur bone. But if we go way back here, this is where we have stromatolites, and this LUCA stands for the last universal common ancestor. It's the last, if you look at the tree of life, all of the structures of all of the organisms, the more than 1 million species on Earth, at some point, this is where things started to diverge. And so we don't know much beyond that for sure. And so there's a stromatolite. Again, it turns out that I took this picture 2 years ago, year and a half ago, actually. I had the privilege of going with a group of NASA scientists out to Australia. And here we're at one of the most famous stromatolite outcrop areas in the Pilbara region in Northwest Australia. It took me 5 plane flights to get there and several hours of driving. And this vehicle is a 4-wheel drive bus that I was sure would tip over. The only question was whether I would be on the inside when it tipped over on the outside. So it was just amazing. And so here I am on just above that area, and this outcrop right here just is packed full of stromatolites. So I had a great time. But why would we go that far back in Earth's history? It's because the surface of Mars is largely very old. And so going to Mars and studying Mars is like going back in a time machine. Most of the surface, whoops, somebody needs to mute the, yeah, if you just joined, thanks for muting. Yeah, so you can see all of this yellow and purple. That is all material that was older than 2.7 billion years on the surface of Mars. And if you look for when was it habitable, all of the sediments were really being laid down mostly in what we call the Noachian period, which is this purple, or the early Hesperian, which is this yellow. And so you can see that almost all of the surface of Mars is from those time periods. But the Hesperian itself was getting what seemed to be inhospitable already by the middle and end of that. And so Gale crater that we were studying was about this, right at the boundary here, about 3.7 billion years when it was formed, and then probably several up to a couple of 100 million years, we don't know exactly, into the Hesperian when we were getting all of this, when it was getting all of these sediments. And then Mars, in some senses, went a bit more dormant, at least on the surface. Maybe underground there were organisms in the groundwater, we just don't know. But that's Mars. And so that's why we're looking for these very primitive life forms, because on Earth at the same time, we would have had just these very, very primitive life forms on Earth. And it's just fascinating to study the history of what we have of evidence of life on Earth. Okay, so here are the rovers. They're in some sense twin rovers, but they have quite divergent goals and very different payloads as well. And so Curiosity on the left had 10 instruments, weighed a little under a ton. Perseverance on the right has 7 instruments and a sample cache and a helicopter, and it weighs just a little bit over a ton. And so that's kind of the big picture of how they're different. MSL had some damage to its wheels. If you've been following it, they're not quite rugged enough, and so Mars 2020 made a little bit narrower wheels that are much more rugged, and we're going to have just as much traction with those, so we're good with that. And there's a lot of other differences. We're going to talk about many of the differences in the payload and the sample cache. So the goals of these two missions are somewhat mirrored with each other, but there's very key differences. Curiosity had a goal of studying the biological potential with looking for organics, characterize the geology, look for habitability, and characterize in a small way human hazards on Mars, not in a very big way. Perseverance has some of the same goals of studying a new region geologically, looking for habitability. We have an instrument that is looking especially for organic materials this time in a different way. And then there is a technology demo instrument that will be producing oxygen, which is going to be needed for human exploration eventually. And then it's to gather samples that could be returned to Earth by a future mission. And that's probably the biggie right there, to gather these samples. So here's a picture of Perseverance. And I think many of you have probably been following it. I'm going to walk you through some of the payload that we have on this rover. First, in broad categories, we have remote sensing. We have proximity, or sometimes called contact instruments that are on the end of the arm. Then we have two environment instruments. One, META, is a weather station contributed by Spain. And then RIMFAX on the left is a ground penetrating radar. I'll show you something on that in just a minute. And then kind of the really interesting ones at the bottom, we have MOXIE, the oxygen demonstration instrument. And then, of course, everyone's favorite is the helicopter, which I'll also talk about as well. And so this helicopter, if you've been following this at all, it's under 2 kilograms, so just about 4 pounds total, but it's got these big blades that are about 4 feet in wingspan, 2 of them, and they're going to rotate extremely rapidly, which they have to do because of the thin Mars air. So this is a JPL Tech demo. It was originally proposed as a scientific experiment. It was defeated just because it doesn't have that much science to it, but it's a potential wave of the future. And so JPL, their director then asked the NASA administration if they could actually develop this with some of the tech demo money that the JPL typically has at its disposal. And the answer was yes. And so they spent $50 million in developing this helicopter. We think it's going to fly, but it's on the hairy edge of feasibility, just because it is so difficult to get something that should be able to fly in a thin atmosphere like Mars and cold environment. One of the hardest things is getting this thing to warm up enough in the morning that its battery has enough energy, can give enough energy to the rotors to get it going fast enough. So we'll see if it works, and we're certainly wishing it does. Here's a picture of Ingenuity, as this helicopter is called, in its stowed position. So it is riding to Mars. It was not part of the original planned payload, and so it is riding to Mars on the belly of this rover. And so it is all tucked away there. And once the rover lands, then this thing will have to, first of all, there's a cover that is jettisoned, and then this helicopter has to unfold itself and then get dropped to the ground, kind of like a baby giraffe being born. And then the rover will drive away, and Ingenuity is on its own. And so we'll try to watch it fly. And if it's successful and actually survives its first several flights, then who knows? We're supposed to go on with the mission. Maybe it will tag along. So we'll see. But I'm excited about helicopters, like I said, because it could be a bit of a wave of the future for exploration. And so one of the things we've been doing since after ChemCam and Sherlock were largely developed is we started a new development for a future instrument that we call OrganiCam. And the idea is if we could make this instrument lightweight enough that it could fly on something like a quad or hexacopter then one of the places that I would love to go with that would be into a Mars cave. And so if you're a Marsophile, you may know that Mars has these caves. They're lava tube caves. And this one has, it's imaged from orbit. Its opening, which is basically a cave-in or an area where the roof fell in, is about 150 yards diameter. And this cave is at least 150 yards deep. It's probably more than that. And it probably goes on for at least a good fraction of a mile and maybe many miles, because that's what lava tubes do. If we wanted to, if we think there was life on Mars, it could easily still be surviving or have remnants in a cave like this. One of the challenges, or one of the problems, is that there are more caves in the younger terrain on Mars, but there are some in older terrain as well, where life might have possibly survived from more clement times on Mars. So we put together this R&D 100 entry this year with our completed.
Roger, your audio's dropped out. Bear with us, folks. Little technical difficulty here.
Am I back?
Yes, you're back. Thank you.
Okay, sorry about that. Thanks for the message. And so I don't know how much you missed. Hopefully not much. This is a little side story, but we've developed this organic cam. We would really like to see it fly someday. And so we actually won this R&D 100 award this year with this invention, and it's cool. So I hope we can use it. It's a fluorescence imaging detector, so we can actually take images of organic material that would fluoresce uniquely with this laser stimulation. And it's a takeoff on SuperCam and ChemCam, actually. Okay, so moving on. Let's see. The tech demo called MOXIE is this in-situ resource utilization experiment that the human exploration side has actually funded. And so it's going to be producing oxygen on Mars from the CO2 atmosphere. Now it uses about 300 watts, and it produces about 10 grams of oxygen per hour. And before I looked this up, I really had no idea that I use so much oxygen. But each human being of the 7 billion humans that we have on Earth are using about 10 grams of oxygen an hour, and about 40 grams of oxygen an hour. And so this MOXIE is only going to be producing about a quarter of the needs of one human. So obviously this would have to be scaled up for future missions, but the idea would be that some mission could actually deposit these on these kind of units on the surface of Mars, get a big reservoir of oxygen, and be producing it continuously as humans are there, and potentially also use this as the oxidizer for the Mars ascent vehicle for humans as well. So it's going to be cool to see that working on Mars. RIMFAX is the radar imager, and this is actually produced and contributed by the Norwegian Defense Ministry, or the Defense Research Institute. And so they have provided this radar that goes on the back of the rover, and it's going to look up to about 180 feet deep, looking at the layers in the rock. Other radar has been exploring Mars from orbit, but never from the surface of Mars. The orbital radar has found buried glaciers and things like that. We don't expect to find ice underneath where the rover is, but we could be surprised. So anyway, this is going to be very interesting to see as well. Then moving along, one of the very interesting instruments for me is actually a pair called Sherlock and Watson. Sherlock's got the coolest acronym, which you can see there. And Watson is its companion. They're both mounted together. Watson is on the right, and it is an imager camera. It's a lot like Molly, the microscopic hand lens camera on Curiosity. But Sherlock is going to be doing fine scale, sensitive interrogation for organic materials. And so it's going to do a small raster just over a few millimeters on spots on the surface. We helped to build this instrument. It's a JPL-led instrument, but parts of it were built here at Los Alamos. And then going back to the stromatolites that I showed earlier, here's a sample of a stromatolite that's analyzed by Sherlock. You can see from its spectrum here that you can see a few organics in the kerogen that still remains in these stromatolites. And then you can see the mineral content as well, which is carbonates and then silicates, chert. And then here's a color map of those different materials as well. And so that is what Sherlock will be doing. We do hope that it's going to see concentrated organics somewhere. And now we're going to turn to the cameras. Perseverance has 23 cameras. Cameras are just so convenient. You're always wanting to look and see, what does it look like here? What can that tell me? The first missions just had things like nav cams and haz cams. The hazard avoidance cameras are essential because you've got to make sure there's no rocks or something right in front of your wheels. But more and more cameras have cropped up in different places around the rover as well. SuperCam has one camera. Mastcam Z is the kind of gold standard for color zoom imaging. And so all of the nice big images that you'll see from the mission are from Mastcam Z. Curiosity had a similar instrument called Mastcam, and this one now has a zoom aspect to it, so it can go up to 110 millimeters and I think down to something like 27 millimeters. I know I'm speaking to a bunch of camera buffs, so I have to give that information. So that will be great to have. So that's going to be most of the camera, most of the bright glossy images that you see. SuperCam has one camera, and it's actually looks like a spyglass because we've cropped out the edges because of vignetting. And so you'll see that. I already talked about Watson as well, and many of the other cameras are more utilitarian. So I'm going to tell you about SuperCam. First of all, we were operating this instrument called ChemCam that I'll show you in just a minute on Curiosity. And we knew it was doing well, but there's a whole community of people out there who really study mineralogy of planetary surfaces. And ChemCam only gave us the chemistry of the surface of Mars. And so there was a science definition team that was convened in 2013 and it was their job to tell us, to decide what was the mission of this rover. And they were kind of packed with mineralogists. And so they said the remote sensing instrument on the next rover has to give us mineralogy. There was a bit of a snub towards ChemCam and maybe an attempt to eliminate us from the competition. Well, we did, we kind of put our heads together and we said, what are we going to do? And we had been developing this remote Raman spectroscopy technique, which is really difficult to do remotely. It's a very low light technique. And we weren't sure if people would completely believe that we could do that much with that technique. And so we also got a group to give us an infrared spectrometer as well. And so we put together two mineralogy instruments. We put it into the same package with the telescope and everything that we had for ChemCam, using the same laser and all of that. And then also included the color imaging. ChemCam just has black and white imaging. And we thought we were probably just doing way too much, and NASA would laugh at it and never think we could actually accomplish this. But in fact, they went for it, and so we had to build all this stuff. And when they announced this instrument in 2014, they called it Swiss Army knife of instruments because it does so many different things. Anyway, just to give you a little background, I think you'll be able to see this video of ChemCam. SuperCam is quite a lot like it. So first of all, it's a point, focus, and shoot kind of instrument. It has two parts. One sits inside the body, down in the rover, and so that's this part. And this is what has the control electronics and the spectrometers. So you'll see some optical fibers up here, these white things. They are bringing the light into those optical spectrometers, and we get one long fiber all the way down from the mast. So here's the mast unit. The laser was on the left. The laser fires through this 4 1/3 inch telescope. It's the biggest optic on the surface of Mars, soon to be joined by SuperCam. And this has an automatic focus to it. Here we're focusing on an iron pyrite, nice big mineral about 8 feet away. And there's the flashes that the laser produces. The laser beam itself is invisible because it's in the infrared, but it produces these nice little flashes of plasma that we use to get the chemistry of the rocks. And so SuperCam uses this same technique. Just before I go to the spectrum, I'll show you the SuperCam instrument for comparison. And so it has a body unit on the left and a mast unit that's sitting on the right in this demo. Basically, this was the night before we delivered the instrument to the rover. And I'm actually standing outside of a clean room, and the instruments are being displayed inside the clean room, so my nose is up against the glass in this picture. This is a beautiful instrument, and so I just had to show this. And the chemical spectrum that we get from both ChemCam and SuperCam looks like this. It covers a large range of the near visible spectrum, going down into the ultraviolet on the left, and then up into the near infrared a little bit on the right. And so you can see the corresponding color spectrum that we would see with our eyes here. And what we get when we whack a rock with a powerful laser pulse is that it ablates the material off that rock, a little bit of material, and it comes off in electronically excited states. Basically, as a plasma, it decays back down and produces that light as atomic emission lines. And by the wavelength of these emission lines, we know the energy of the electronic transition, which tells us which element is producing this. And so we have hundreds of atomic emission lines. We calibrate this whole spectrum against a large library of standards, and then we have the elemental composition. And we can do this out to 7 meters away from the rover, so about 25 feet away. So that is, it was an unknown technique for planetary science until we proposed it to NASA with ChemCam, and it has really caught hold. And in fact, the Chinese rover Tianwen-1 that is on its way to Mars now also contains a ChemCam-like instrument as well. And so this will be the second and third LIBS, laser-induced breakdown spectroscopy instruments on Mars. Now, why is SuperCam super? It turns out we have these mineral techniques, and so you can take, say, a chemical composition like this calcium carbonate that you're seeing in the middle here, and it turns out that calcium carbonate will fit into different mineral structures. On the left, you have calcite. Calcite is a major constituent of limestone that is all over on the surface of the Earth as a sedimentary rock. On the right, you have aragonite. Aragonite is actually produced by organisms, coral, and so on. And so it is a hexagonal lattice. Now you can get the same chemistry from ChemCam, but you won't know which mineral structure it is. And so that's why SuperCam, with its mineral technique capabilities, is much more useful. We can do both. It's also, once you know the mineral, it's also useful to know the chemistry as well. So SuperCam is going to do both. So you saw the flash of plasma that I show on the left here. On SuperCam, we'll actually double the frequency of the laser or cut in half the wavelength. Then we have a bright green laser instead of the infrared. And so it gives us these brilliant green flashes. We don't focus that to a tiny spot. And so that covers a bigger area, and it basically tickles the surface and excites the molecules without blasting them and breaking them. And so by exciting the surface of the rock, then we get this molecular technique called Raman spectroscopy. And so it gives us these emission peaks. If we block off the laser light would be at 0 on this emission spectrum. And then some distance away, modulated by the bond strength of the molecules, you see these peaks. And so you're seeing these little molecules vibrating around there. Infrared, which is indicated as IR there, gets different kinds of molecular vibrations and stretches than does Raman. And so the two techniques that SuperCam does for mineralogy are very complementary. And so we put them together in a toolbox effectively. Now, both ChemCam and SuperCam use this laser technique, and so they kind of blast the dust away. The shock wave actually produces a little, or the plasma produces a shock wave that removes the dust. And so you can see that on these targets, and then we do a raster of laser pits. And so we'll do that with not just the LIBS, the chemistry technique, we'll do it with the Raman and the infrared as well. So we'll get all of these techniques from the same spots. When we shoot down a drill hole, that drill hole is the size of a dime. Remember that our instrument is sitting up on the top of a mast about at eye level. So it's like taking a little laser pointer and dropping a dime or throwing a dime on the ground and then shooting up and down the side of Roosevelt's cheek on the dime. We have very accurate pointing with this rover. Now, SuperCam has one instrument that we added, or one technique that we added after selection, and that is the microphone. Nobody has heard any sounds from Mars. There were 2 missions that brought microphones, and none of them have been successful. Hopefully we don't jinx this mission too. But there's the microphone circled in red. The rest of SuperCam would sit inside of an enclosed box. We have to have the microphone on the outside, and so there's a tiny little wire that connects this. That microphone has a scientific purpose. It is going to be listening to the laser impact on the rock. This makes a zapping sound, and that zapping sound actually changes in intensity depending on how hard the rock is. And so we're going to, without ever touching that rock, we're going to determine how hard the rocks are and some other characteristics. We can also turn the mast and get the wind direction and the wind speed from this microphone as well, although there's another instrument, Meta, that can also do that, can also get the wind statistics. So we're going to do a lot with this instrument. Now, in terms of where we're going on Mars, those of you who are Marsophiles know that Mars has kind of 2 different regions. It has the southern highlands and it has the northern lowlands. The southern highlands are pockmarked with craters. The northern part may have been an ocean at one time because it is so featureless. But the region at the edge of the southern highlands is perhaps of the most interest just because that's where the water is moving north towards the lowlands. And so we took advantage of that with Gale Crater over here, and we're going to take advantage of that with Jezero Crater, which is the target region for Perseverance. And so here's an image of Jezero. It's only about 50 kilometers in diameter, so it's about 1/3 of the diameter of Gale Crater, where Curiosity is. Look at this. We can see an inlet valley here. There's also one just off the picture up in the top, and then there's an outlet channel over here. And so we know this was a crater lake for some amount of time, about 3.7 billion years ago. And we're hoping that there's also a bit of an igneous layer in the bottom of the lake. And then there's this great delta feature here. We've never landed near or gone near anything like it with a rover on Mars. So looking at that a little more carefully, you can see just some of the meanders, some places where the river channel was taking it, just as at the delta of the Mississippi or other rivers on Earth, where they're emptying into a large body of water. And so we're actually planning to, we have the landing ellipse that actually overlaps this delta. And there is a special technology that has been developed called terrain relative navigation that should help this rover package avoid the steep slopes. So we may land on the delta, we may land just below it in the lake bed floor, but we should be avoiding the cliffs, God help us. So, and that's the plan for the mission. Now, the reason we're really interested in this area is several-fold. I'm kind of blinking back and forth some of the mineralogy maps that you can see from orbit. And so what we see in blue is clay minerals. What we see in red is igneous minerals. And then the yellow is sort of a bathtub ring around this crater in carbonate. Now, with a carbon dioxide atmosphere, you would think that Mars would have carbonates all over the place, and it doesn't. And so we still don't understand why not. We're hoping to understand a bit more of that as we actually study the carbonates that we will find here. So that's one enigma that we hope to solve with this mission. There's many others with how the delta was formed and the lake bed floor and so on. So what is Perseverance going to do to collect samples? It's got two instruments on the arm. It's got a large drill there as well, and that drill is a coring drill, and so it's going to be collecting drill cores. And I've got a little video here that should show us how that works. Hopefully this will transmit to you well. So there's the coring drill. It takes the drill and the cores. The cores are now inside of a metal tube, and those get transferred into a sample cache system through this turret that then brings it to a vertical position. And so that tube then gets handled by this secondary arm right here. There's an imaging station, there's a capping station, and then there's storage. And all of this technology here is just amazing. I really hope that it works throughout the mission, but all these mechanisms are prone to getting dust in them and things like that. So we'll just have to really hold our breath and see how this all works. So there's 38 tubes that can be filled with drill cores or soil samples, and then there's a chance to release these, and then they'll get dropped on the ground. And so here's sort of a strategy. We can drop several drill cores. We can go then to a riskier place with the rover and then bring the cores back. We may drop more than one depot, which is the place where we drop them. And so just depending on how this whole mission unfolds. There was a several-hour meeting this morning that was open to the public. Actually, people from this group could have been a part of that, just to talk about what the strategies should be for the sample caching. So we'll see how that all goes over the next few years. Then the plan is NASA is putting a lot of money right now into the next missions. One, to bring a rocket to the surface of Mars. It's called the MAV, or Mars Ascent Vehicle, which would then, with a small rover, and it would then collect the samples and put them into orbit. Then from orbit, we'd take another mission that would then bring this back from low Mars orbit all the way back to Earth and get them into a capsule that could enter the Earth's atmosphere. So that's the plan hopefully by 2031. It's an ambitious plan, but we're getting farther along than we've ever gotten before on this. Here's some plaques that have the names of the people here at Los Alamos that built our parts of the instrument. And so we're very proud of what we did here. My name's going several times to Mars. And just before I close, I just thought you might be curious about this. I think you'll be able to hear Matt Damon talking lovingly about the ChemCam instrument. This is an outtake from the movie The Martian.
Hey, Johansson. I know you don't like it when I touch the ChemCam, but I'm touching the ChemCam. A lot.
So breaking the rules there, I suppose, but the landing is now scheduled for February 18. There's actually 2 other missions on their way to Mars I can tell you about that are going to get there a few days before ours, but none will land before Perseverance. And so we're holding our breath, less than a month away now. And we hope that you follow the Perseverance rover as it goes in for this spectacular landing. And there's a view of the rover just as it's getting capped up in the capsule before the launch last April and May. So thank you very much.
Thank you very much. So I'm sure that gives everybody a more intimate appreciation of what is in store after the 18th. And let's have some questions. You can throw your name in the chat room and I can call on y'all.
Yeah, if you want to read the chat questions to me, or people can just do it vocally as well, I'm sure.
Yep.
What's the launch vehicle, just for the of the
Yeah, it was an Atlas. I believe that's correct. Yeah, and so it's 210 feet high. Yep. And so it's been a workhorse for many years.
Great. Thank you.
It's like Greg Frederick has his hand up. Greg, you can just unmute yourself and ask.
So did Dale Hall.
Oh, excuse me.
Yep.
Yeah, I had a question. I understand that there are various types of minerals that are only produced when you have life on a planet. For example, our planet. And on a lifeless body, only certain minerals would be existing. So are you guys taking into consideration all the different types of minerals that might be indicative of life that might have been on Mars in the past?
That's a great question. There are so there's a lot of complication, of course, with this, which is why it's not a simple answer. But so on Earth, there are things. Let me just give a few examples. First of all, there's a whole class of oxalates, and so that's something that we're looking into, which may be a degraded form of some of the organics that were in quite a different form long ago. But what we see near the surface of Mars has been bombarded by radiation for millions of years. And so it turns out that the organics that we're finding are ones that are kind of survivors, or sort of things that the organics have converted to during their sort of degradation. And so we find a lot of thio compounds, that is sulfur-rich organics, which seems to help them perhaps survive as organics still. And then we think we're finding some oxalates. But another whole class of things is manganese. I don't remember if I have this in my backup slides or not. So let me take a quick, yes, I do. So if we look at the sort of the different branches of life, without going into this in a lot of detail, so this is a little nice little diagram you can find online. These are sort of the different categories of life on Earth. And if we look sort of to the left-hand side, which is the a lot of our plants here, you have photoautotrophs, which make their energy from light, and can work off of that. If they're not getting their energy from light, you're generally looking at a more primitive organism. And so if you look back in the history of life on Earth, so before cyanobacteria, basically, and before there was oxygen on the surface of the Earth, because cyanobacteria, we think, actually produced a lot of the oxygen that we have on Earth from when photosynthesis was, in quotes, invented. But before that, we think that the precursors were these sort of rock-eating types of life that use the valence state changes, the electronic changes in these metals to get their energy out of the rocks. And one of the strongest ones is from manganese. And so if you look out in the desert Southwest, you'll see these dark rock surfaces when the rocks themselves are not dark. This is called desert varnish. Usually there's a lot of manganese there. And you'll find this in other places as well. And there is a key paper that was published about 8 years ago now that suggests that manganese fixing bacteria were the precursors and you find manganese around in, I believe, in some of the structure of the early cyanobacteria. So we look for manganese on Mars. And it turns out that we have started finding some high concentrations of manganese in certain places on Mars. We don't think that's necessarily indicative of life, but what it is telling us is that there is some strong oxidation potential in the groundwater where we found these, or at the surface where we're finding this high manganese. And so that's one of the things that we're really following closely. I have a colleague here. She was a former student and then a postdoc, and now she's a staff scientist here, Nina Lanza, who's been really studying manganese on these missions. And so that's one of the ways we're also looking for evidence of past life on Mars. Thanks. That was a good question.
Thanks.
Yeah. So we have two people ask the question, what day will Perseverance land?
Yeah, so it's February 18th. So think of Valentine's Day, which is the 14th, and it's 4 days after that. And it's a Thursday. It's a great timing for us in the U.S. It's landing in the afternoon here in the U.S. So mark your calendars and just go to nasa.gov, and you'll be able to watch the landing. Everything is just like things with the inauguration or whatever other public things you're seeing these days. Everything is virtual. And so you'll have just as good a front row seat as I will. And so go for it.
All right.
February 18th.
Fabulous. And Riyadh had an organics testing question. Riyadh.
Yes, thank you. Yeah, my question is basically, how do you decontaminate the instruments that are going to be looking for organics so that nothing from Earth is detected later on by mistake? Thank you.
Yeah, no, that's a great question as well. We don't want to contaminate Mars, and so there's different levels of sort of concern for contamination. And NASA has an office called the Planetary Protection Office. And a lot of people laugh when they hear that, but it is totally serious. And so we have had to follow the planetary protection guidelines. And sometimes things get a little bit heated because, of course, the engineers, they want to do the easiest thing possible, but the Planetary Protection Office is like, nope, no, you got to do the sterilization. And so anything that touches the surface of Mars has to be sterile. And so as you look at the pictures, I think when I showed the rover going for its last view here, all those wheels are covered, right? That is, they're sterile. Anything that's going to touch is planned to touch the surface is sterilized. Now the rover itself is not totally sterilized. It is certainly wiped down. It is anything that is on the surface of the rover has to pass a bio bio load level. And so SuperCam is actually inside of the rover, at least even on the mast, it's covered in a box. But we have calibration targets that are out on the surface of the deck of the rover. And those had to go through what's called a dry heat microbial reduction bakeout. And so that was at least, I believe, 130 degrees C, so well above boiling temperature for something like 72 hours in a vacuum chamber. And then then it actually got swabbed when it got to JPL to make sure that it had that very, very low bio burden. And so that's the case. Then for the sample tubes, and I'm not sure if I have a backup slide showing, this was when I thought the mission might actually succeed. I probably don't have that in my backup slides. But back in May, we got this picture of them installing the sample tubes in the underside of this rover, as you see it there, just in this, maybe I can indicate with my mouse, just in this dark region right here. That was the last thing to go in the rover, and I think it might have even been in the capsule already like this. And those sample tubes were ultra sterile. They were the last thing, like I said, to go in because there were so many tests to make sure that they were really very, very sterile, because the last thing we want to do is bring back biota that we actually sent there in the first place and think that it's Mars life. So that's why, and when there are blank tubes as well, and so those blanks will go through the whole mission and come back as well, just to verify, look, hey, we didn't put anything in the blank, so if you find biota in there, then it's back from Earth. So hope that answers your question.
All right. We've got a question from YouTube. Can the Mars caves be used as a survival situation for astronauts if a solar storm strikes? And would that make them a possible consideration for a landing site?
I didn't get the very first part of that. Can what be used?
Mars caves as
Oh.
a survival shelter for astronauts.
Yeah. I think down the road we will be targeting Mars caves just because they are natural habitats. We don't have to build something there. But looking for the picture of that again, the Mars caves that we see now from orbit are these ones that have these deep drop openings. Basically, they're only accessible by a helicopter. So I don't think Mars caves are going to be necessarily targeted early on, but I could be wrong. If there is a cave that has that we think has a more horizontal opening, I suppose that could be possible. So it is a very interesting thought. And certainly later on, if we get to colonies, I think some of those will be looking at caves for a great place to at least store things, if not to have humans living in them. So great.
All right. Any other questions?
Yes.
I figured. Go for it, Dale.
I guess part A of my question is how deep does the drill go? And part B is the drill doesn't look like it goes that deep to me. And wouldn't it be better if it could go a lot deeper to get below where the cosmic ray intensity was so large?
Yeah, that's a very good question and point to your question as well. So, oops, I'm going in the wrong direction here. I was going to try to bring up the picture as we talked about it. So there we are. These are, I believe, about 13 to 16 centimeters long. So yeah, so they're about 5 inches long, not that deep. Curiosity had a drill that is about that deep as well. And so we're not getting very far below the radiation pummeled surface. What we can do to get to more or less sheltered places is go to a sedimentary scarp. So if you have a small cliff, and if you can go nearby that cliff, it's likely that that cliff has also been migrating as the surface gets deflated or eroded away by the wind. And so that's, in fact, some of the age dating that's been done, which is another whole topic with the Curiosity rover, suggests that this is in fact the case, that if you're drilling near a scarp or a small cliff, that region is probably only exposed within the last tens of millions of years. And so you avoid some billions of years or hundreds of millions of years of radiation. So that's one way that we're planning to use, basically to collect samples that are less subject to the radiation. Now, the Europeans are taking another approach. They're saying that ain't good enough. And so their ExoMars rover, which was to launch this year, but it's been delayed 2 years now, last year, is equipped with a 2-meter deep drill. And so they're planning to go the whole way and just drill deeply. And we hope that drill works and can bring up material from that deep. So different approaches by the different countries. And but the Europeans are going to be helping us with the sample return from this mission. And so they have a vested interest in making sure we get some radiation sheltered samples among the samples that we get. It's a great question.
All right. Well, thank you so much. Let's another round. Oh, Dale's got one more? I guess there's always one more from Dale.
This will be the last. We are going to have Dr. Gilbert Levin speaking to us, I believe, on March the 1st. He was a scientist involved with the Viking mission back in 1976 or whatever it was, and claims that they found life. can you comment?
Yeah, I will comment, and you're going to get an hour of his time later. So, yeah, he's an interesting character, and so he was the leader of what's called the labeled release experiment on the Viking missions back in the 1970s. And this labeled release experiment was one where the Viking lander, the very first lander successful on the surface of Mars, scooped up some material, some soil, and brought it into the lander. And there was a small chamber, and the idea was they would provide some water to this sample and see what happened. And so what happens is, in fact, this soil gave off carbon dioxide. Now, that's what would happen on Earth. If you put some soil in a container and give it some water, living organisms inside of that soil will start to respire and grow and give off carbon dioxide, especially if it's been in a dry climate, but you've got the seeds and the spores in there to do that. And so you might think that that would be evidence of life, but that's just one experiment. And so you have to look at the whole of things and what's happening. That was a bit of a mystery for a long time. And but the Phoenix lander, which landed in 2007, studied the soil for some of the what's called wet chemistry, or they did some chemistry experiments that involved solutions, and they found that the Mars surface, which is very desiccated in a sense, has also pummeled by this radiation to produce some interesting chemical compounds that we generally don't have on the surface of the Earth. And so what it has is perchlorates. These are highly reactive chlorine compounds. And if you provide them with water, they go nuts and they start producing oxygen, which they've been holding on to. And so the perchlorates are the complete answer that you need for this experiment. But Gil Levine is going to certainly argue against that, but he is kind of in a 1% category on that one, kind of on his own. So you can enjoy your time with him, but take it with, if I can say this, take it with a grain of salt. Of course, he would be upset at me for saying that, but that's the way it is. And you can look in the literature and you'll find that same thing.
All right. Well, thank you again. Fabulous. Pleasure having you tonight. And
my pleasure.
Normally we would ask you to join us at a restaurant, but COVID. But then again, we're that way. We might not be able to have you tonight anyway. So
next time I'm up in the Warren area, I'll ask to join.
Fabulous. All right. So stay tuned, everybody, for the email blast for discussion group / virtual open house night. Everybody be safe. And for those of you not attending the virtual open house, we'll see y'all at Virtual Cranbrook on the first Monday. See y'all.
Bye-bye, everybody.
Night, everyone. Bye-bye.
Everyone.
Great talk.
Roger.
Wonderful.
Indeed.
Yeah, thanks all. God bless.
Good night.
I'm signing off, you guys. Good night.
Good night.
I was so glad he came.
Yes.
That
Indeed.
was very, very exciting.
Yeah, that was excellent. We may need to edit the end of that YouTube feedback.
Hi.
Just never mind.
Oh. All right. Good night, everybody. I'm ending the stream.
Good night.
Bye-bye.